You want to give me any indication? Yes, no, sort of? How many people got half done? How many are over half done with that lesson? Just 1, 2, 3, 4, 5, 6. 5 of you? 6 of you? All right. That means a lot. That means half this class is way behind already, and we're just on day 1.
That last section, it was like 37 to like 40 something. That was kind of weird.
That got weird on you?
Yeah.
I think the end, wasn't it? Just use your graphing calculator?
Yes.
Yeah.
Something like that? Okay. Well, we can look at it if there's time in the end.
It's just, I don't know if I need to use that table or.
If it says evaluate the limit numerically is the table.
Okay.
Graphically is graphing it, or let your calculator graph it. Algebraically is this stuff we were doing yesterday. I don't know what it said. Yeah, I'd have to look. Okay. Can we start this one? You guys ready? We're going to take the limit of cosecant of x over cotangent of x as x approaches what? Pi. Try direct substitution every time. What if it works? If it works, you're done. So let's do that. Let's try direct substitution here, here. So this would be cosecant of pi over cotangent of pi, right? Now where's pi? On the unit circle, pi is right here. What's this point? -1, 0 with a radius of 1, right? Now cosecant is the reciprocal of which one? Sine. Sine is y over r, so this will be r over y. Cotangent is the reciprocal of which one?
Tangent.
And tangent is y over x, so this will be x over y. What if this thing works? What if we get an answer? Well, then we're done. Okay, what's r over y? Here's r over y. 1 over 0. Which we know to be undefined, by the way, right? That's undefined. Okay, what's cotangent of pi? X over y, x over y. Okay, that's -1 over 0. Okay. And when you look at this, guys, if you look at it and you did the mathematics behind it, it's really just 1 over 0 times the reciprocal. What are you getting? 0 over 0. What does that mean? The limit does exist. There's an answer. But that's just a hole. That's a hole in the graph is all it is. Okay, so now we got to go find it. Oh boy. How do you find that? Well, here's what you do. You take your function, take this function, and you simplify it. Now, you got to go back to trig. This is chapter 5. How did we simplify something like that back in chapter 5?
You flip it around like the signs like the cotangent.
Okay, what do you mean? What do you want?
Wouldn't it be like, it wasn't chapter 5 about that?
Identities.
Okay, so cosecant is 1 over sine.
Okay.
So you times it by sine.
Wait. 1 over sine of x. That's what it is, right?
And to like make the way you go like times sine over 1, and then cancel out.
Right. I get that, but shouldn't we take care of cotangent? Remember how I said always get things back to sine and cosine, because sine and cosine are the basic functions?
So it'd be like
What is cotangent?
It'd be cosine over sine.
She says it's cosine over sine, is it? Yes. It's cosine over sine. Oh, well, that is really this, and I actually took it and multiplied by the reciprocal. What would happen? Out with the signs, and the answer becomes 1 over cosine of x. Right? But can I simplify that a little bit? What's 1 over cosine? It's just secant. So then this becomes secant of x. So you see all this stuff here, guys? This stuff right here is just secant. Now, here's the question. What's the limit as x approaches what? Pi. That's what the question was, right? Here's pi. Pi's right there. -1, 0, radius 1. What's secant, though? Secant is the reciprocal of cosine. Since cosine's x over r, secant's what? R over x. Oh, okay, well, what's r? 1. What's x? -1. So this answer would be 1 over -1, or better yet, the limit is just -1. So there was a limit. There is a limit. It's -1. Now, you will run into that stuff in your assignment, and here's the bad part. The bad part is, this is chapter 5. You have to remember all the things we did in chapter 5 with identities to simplify these things. And that's the hard part, if you ask me. Because your memory has to go back to January. And where are we at now?
May.
We're May. How good's your memory? I don't know. So, now you could kind of go back to the last couple problems in day 1 and probably finish them. Okay? Can I move on? Good. No one said a word, so I just did. All right, now we're going to look at one-sided limits. One-sided limits is you're going to look at the number you're approaching from just the left, from just the right. That's a one-sided limit. Okay? So here's what it says. What is the limit of f of x as x approaches c? Guys, I can't read mine, but does it have a little negative back here? In the back? You say yes?
Yeah.
Okay. So since
Did we
it's...
skip one?
Did I skip it?
Yeah, we didn't do last one.
Oh, we didn't do that one. We didn't do this? Okay, sorry. I did skip one. I'll get there in a second. Here it says the function f of x is graphed over there. What is the limit of f of x as x approaches 3 from the left? Can you just see it? Here's 3. As we approach 3 from the left, we get that answer, that answer, that answer. So we're getting answers like this. We're approaching what? 3. It's right there. The answer's 3. Pretty simple, right? What is the limit of f of x as x approaches 3 from the right? Well, from the right, let's see, we're getting that answer, we're getting that answer, we're getting this answer, then this. So we're getting all these answers from the right. So we're approaching what? This point. We're approaching 4, right? So from the left, we get 3. From the right, we get 4. Okay. Well, here's the deal. They're going to try to tell you what a limit is. You already know, but here's what they do know. They tell you, when you evaluate limits, you've got to evaluate a limit from both sides. One-sided limits means come from one side, then come from the other side, and hopefully we narrow in on one number. Well, here's what it says. The limit of f of x as x approaches c from the negative side, or basically from the left. What was the answer on the previous slide, guys? On the previous side, what was the answer as we approach c from the left? 3. Okay. This one says now, if there is a limit, you got to approach c from the right. So this one says, evaluate the limit of f of x as x approaches c. I hope you have a plus sign there, don't you?
Mm-hmm.
You do?
Yep.
Okay, so this says from the right, from the positive side. I shouldn't say from the positive side. I should say just from the right of c. Well, on the previous slide, what was the answer?
4.
Yeah, previous slide, the answer was 4. 3 from the left, 4 from the right. Hey, just a quick question. Do you think there's a limit on the previous slide? Or do you think it does not exist? Does not exist, because I've already told you, you've got to go towards one number, not two numbers. This next slide is the definition. How do you know if a limit truly does exist? The limit of f of x as x approaches c will exist if and only if, when you evaluate the limit from the left of c and from the right of c, they're exactly what? The same number. It's got to be 3 from the left and 3 from the right. 5 from the left, 5 from the right. That's the only time. So guys, when you just look at this graph, do you agree that the limit does exist? Because, here's C. As you approach C from the left, look, here's all your answers. You're heading towards that point. From the right, here's all your answers. You're heading for the same point. It does exist. So just from a graph, you can tell if it does exist. Why doesn't it exist over there?
It's not continuous.
It's not continuous. Good answer. I was thinking you were going to say something else.
It sorts different ways.
From the left, you're approaching what number? Looks like that number. From the right, you're approaching a different number. Doesn't it say they have to be the same number? From the left, from the right, you have to approach the same number. You're not. You're approaching two different numbers. Now, Darian didn't say it that way, but she said it's broken. When the graph is broken, usually it does not exist. And I say usually because, what if I would have said, let's just pretend this number is 4. What if I said, is there a limit as x approaches 6? Yes or no? Yeah. As you approach 6, from the right to left, look, there. Oh, there is an answer. Because Darian said, because it's broken, it doesn't exist. Yeah, that's true. If it's broken right at that number, at C, then you're right. Okay, can I move on? Did I surprise you on any of that? Almost everybody today shook their head no. You didn't surprise me. I knew all that walking in the door today. And that's good. Okay. All right. It says use one-sided limits to determine if the limit of f of x exists as x approaches 2. Okay, guys, I'm going to try to speed you up a little bit because I just know we have a lot to do. So I'm going to do this for you. I'm going to graph this function right now. Okay? And here's how I would graph it. I hope you listen because you're not going to really do it. I'm doing it. You're just going to agree and copy. It says for all x's less than 2, right? Well, if I stick 2 in, what do I get? Thought I heard somebody say it. 5. Does anybody know why I did that with an open circle? Why did I put a hole?
It's not less than or equal to. It's just less than.
Well, does 2 truly exist in this function? No, 2 is not involved. It doesn't say equal. So that's why I did that. Now, if I pick a number less than 2, like 1, I will get 2. If I pick 0, I will get 1. If I pick -1, I will get 2. And look what it does. It forms a parabola. But only a piece of a parabola. Okay, what if I graph this equation, or this function? Is this a parabola? No, this is linear. This one, when you plug in 2, I'm going to plug 2 in again. I will get 5. Why did I go open on 5?
2 doesn't exist there either.
2 doesn't exist in this one either. So the number 2 is a hole. It's just a big hole. All right. When I put in numbers greater than 2, like 3 or 4, when I put in 4, I get out 3. So there it goes. It's a line. Now tell me right now, just by what we talked about, does the limit exist as x approaches 2? What do you think, guys? Yeah? Colton says yeah. Kayla, Will, you guys okay with this? Yes? Is it yes? Colton says yes. Do you agree? As you approach 2 from the left, 2 from the right, look, you're getting closer and closer to what number? The same number. That number happens to be 5. So what's the limit of this one? As x approaches 2, the limit's 5. By looking at a graph, you can tell all that. You can see it. This is using one-sided limits. From the left, from the right. Am I approaching the same number? Yes, I am. It's 5. Okay. All right. This is exactly where we should be right now today. So, I got 30 minutes. We're good. So we might have time for questions in the end. Okay. Are you ready? This is a sneak preview of the next lesson coming up. The next lesson is all about calculus. It's what they do in calculus almost the entire year. So guys, we're just taking baby steps towards calculus right now. All right, but what I do with you right now is when you're all done, you'll get an answer and you'll go, oh, what does that mean? And I can't tell you until the next lesson. So what I'm doing right now is I'm just practicing how to get the answer, and the answer today doesn't mean much to you, it's just an answer. All right. Now, you ready? Here's what you're gonna do. You're gonna take a function. I'm gonna give you a function every time. Now, just so you know this, a function, you know you have a function because it says f of x and it says what? Equals. If you are told f of x equals, they're actually giving you the function. What does your function equal? 2x plus 1. Sorry, 2x squared plus 1. All right, now what do they want you to do? They want you to find the limit of this function as h approaches what? 0. Now, there's what they want you to do. To me, this is just an expression. This is division. You will take all of this on top, divide by h. That's what you're going to do. And by the way, you will do this today, tomorrow. You will do it Monday, Tuesday, Wednesday, and you will do it on the quiz next Friday. So you got to get good at this. What's the limit of this? Well, first, I'm going to go direct substitution. I want to see if I can just plug a number in and get the answer right now. So if I plug in 0, what do I get on the bottom? Well, that's easy. 0. What do I get on the top? F of 2, 2 plus 0, minus f of 2, well, f of 2 minus f of 2 is 0 over 0, which means what? It does exist. There is a limit to this function up here at h, as h approaches 0. Now watch what we do. We take the division problem. This is just division, and we work it out. Now, it's amazing. It is amazing how many people get lost in this. You ready? I'm not going to do that yet. Watch. What would you do if I told you to do this? What would you do? F of 3.
Plug in 3 for x.
Plug in 3 for x. 3 goes in for x. You'd say 2 times 3 squared plus 1. That's 9. 2 times 9? 18. Answer's what? 19. That wasn't hard, was it? Okay, stick with me. It's the same thing. Except, it's not a number. I'm not telling you to put the number 3 in. I'm telling you to put the number what in? 2 plus h goes into your function back here. Here we go. Now we're starting. So it says 2 times your number squared plus 1. But what's the number you're putting in? 2 plus h is the number you're putting in. It's not like it's an easy number, 3, 4, 5. Okay, then it says to subtract, right? So put a minus sign down. Then it says to subtract what? F of 2. That number, f of 2, gets plugged into your function. So I'm going to say subtract, what am I going to subtract? F of 2, 2 goes in. So I put 2 in, I fill it in, I got to figure that out. And it's all divided by what letter? What letter am I dividing by? H. So put an H underneath. Okay, now it comes down to this. Can you guys work this out? Okay, 2 times 2 plus h squared plus 1. Well, 2 plus h squared is 2 plus h times 2 plus h. So you're going to FOIL that out, or if you can do it in your head, do it in your head. 2 times anybody got it?
H squared plus 4h plus 4.
Oh, okay. So you put the, you kind of reversed the order, didn't you? Okay. I might have done 4 plus 4h plus h squared. It doesn't matter how you write them in there. Plus 1. Okay, minus. Okay, wait a minute. What's in here? What is that? 9. This is just 9. So it says minus 9. Okay, over h. I see a multiplier, so I'm going to distribute that through. It's 2h squared plus 8h plus 8 plus 1. Take away 9 over h. What do you notice about the numbers in the back?
Equal
Equals 0.
Yeah, it don't yeah. 8 plus 1. 8 plus 1 is 9. 9, take away 9, gone. They're all gone. So what's left is this over h. What do you think I should do right here? It's
Pull up 2h.
what?
Did you pull up 2h?
You're factoring, right? Yeah, he's factoring. And I would too, Corey. I would factor out a 2h. The GCF is 2h. The reason I want to factor it out is because I want to cancel these h's out. What's left? H plus... Whoa, I did that wrong. H plus what? 4. What do you notice about these h's? They're exactly the same number. I'd cancel those out in a second. So you get what? 2 times h plus 4, right? That is the simplified answer of what they asked you to do. But do you remember the question in the very, very beginning? Or do I have to scroll up there for you? What do we have to do to this thing?
Find the limit as it approaches.
Yeah, you guys, we're not done. I hate to tell you that. There's one more thing we have to do. What's the limit of that function as h approaches 0?
8.
It is 8. Now do direct substitution. Put it in. 2 times 0 plus 4 is... There it is. The answer was 8. Got it? I tried to go as slow as I could. Are you okay? Okay, we got to do this again and again. I think there's two more of them, isn't there?
Yeah.
Yeah. Okay, let's go. You will get better and better as you do it, I promise. Okay, this one. Do the whole thing over again. Look, it's the same division problem. Same division problem with what function? Where's the function? What?
2x minus 5.
Yeah, it's right where you see the equal sign. This is your function. Your function, f of x, is right here. That's your function. Now, Before I begin any problem though, guys, I typically do the direct substitution thing just to see if it is a number, and then I'm done. If I put 0 in for h, I get 0. If I put 0 in for this h, I get f of x. Take away f of x. Oh, look at that. It does exist. But that's not the answer, so go find it by using this division expression. I'm trying to give you some time so you get started without me. It's the first thing you should have done right there. Take the number x plus h, put it into the function 2 times x plus h minus 5. Then it says to subtract. Did it? What am I subtracting? Put it in parentheses. What am I going to subtract? F of x, which basically means you take this x and substitute it in for that x, and does that change that expression? Not at all. So really, when they say minus your function, just copy your function down. There. Did I lose you on that? Minus f of x. Oh, just subtract my function. Over what? Over h. Okay. This one's really not that bad. I'm hoping you're getting ahead of me. You're not waiting for me. Did you do that? Did you run your negative through? So you changed it to negative 2x plus 5? And here you got what? (2x plus 2h). Take away 5. Take away 2x. Add 5 over h. Look at all the cancellation. A 2x with a 2x, minus plus. A plus 5 with a minus 5. All you have left is 2h over h. What do you notice?
Cancel out the h's.
The answer's what? I keep saying the answer's 2, but I didn't mean to say that. I'm sorry. The simplified expression is 2. We still have to do one thing, and that is give me the limit as h approaches what? 0. Do you know the answer? Direct substitution. Put 0 into the h. Where's the h? There is no h. So what's the answer?
2.
2. The limit is 2. Do you remember me doing this the other day? I said when you get a number for your function, do you remember if you graph that function, what does that function look like? Horizontal line like that. 2 is this function, right? I don't care what h you pick. Hey, pick h right there. As I approach h from the left, from the right, look, go up. What do you hit? You hit 2. That's why it's 2. All right. That one's actually not too bad. That one, the work was pretty easy. This next one, it gets really ugly. It gets messy.
So are you saying direct substitution doesn't work on this one?
Hate to tell you this, direct substitution only works on a few of them. We can try it. Let's do it. Ready? And if you say this and this for direct substitution, you're going to get 0 f of x. Take away f of x. Still get 0 over 0, which is telling you it does exist, but go find it. All right. So now, where's the function? Look up here. Where's the function?
Equals.
Where the equal sign is. It says right here, your function equals this. Take your function and evaluate your function when you plug what in? X plus h goes in and x goes in. Now plug those two things in without my help. See what happens. When x plus h went in, you should have wrote the square root of what? X plus h for x, followed by what? Minus 1. Then subtract what? F of x. Well, f of x is right here. F of x is what? Yeah, square root of x minus 1. There, did it. Oh, over h. Sorry, I forgot the h. Okay, guys, all you did is put the numbers in. If I went in right now and I stuck my h in right now, if I did direct substitution right now, you'd still get 0 over 0. You haven't done anything. So how do I simplify that ugly, ugly look? Yeah, go ahead.
You multiply it by the square root of h of x plus h minus 1 plus the square root of x minus 1.
She could have just said multiply by the conjugate. You're right though, Ivy. That's perfect. Just multiply by the conjugate, and the conjugate is exactly what Ivy said. It is the first square root, don't change it. The second square root, or the second number, change it to positive. There you go. And then down here, you'd have to do the same thing. Square root of x plus h minus 1 plus square root of x minus 1. The nice thing about conjugates, you just have to do first, last. So first, that times that is what? X plus h minus 1. Done. The second one, be very, very careful, guys. What's a negative times a positive? Negative. So you're going to get a negative whatever answer. But the answer is not just a number. It's actually an expression. What is the square root of x minus 1 times itself? X minus 1. And here's the problem. The problem is, it wasn't minus 10 or minus 12. It's minus x minus 1. Which means you have to do what? Run it through, right? And get what? Negative x plus 1. Over this little mess here. There. Now look closely at the top. This is gone, by the way. I already took care of it. What cancels?
1 and negative 1.
1 and negative 1.
X and negative x.
X and negative x. What's left? H. Over H times this little mess you got here. And then plus this. Right? H's do what? Cancel. When you cancel an H over an H, you're supposed to put 1 over 1. So really the answer, I did it again. The simplified expression is 1 over what?
Square root of x plus h.
Minus 1 plus, right? But remember, you're not done because you have to do this. Find the limit as h approaches 0. So what do you have to do?
Plug in 0 for h.
Yep, just direct substitution. See if you get an answer this time. Ready? If you did that, you'd get basically 1 over the square root of x minus 1 plus square root of x minus 1.
X plus 1.
All right. You know what? You're not getting a number. You're not getting 8. You're not getting 2. You're getting an expression. This expression will give you the answer if you knew what x was. You don't know what x is. So you're done. But there is one thing you could do. This is the square root of a number plus the square root of the same number. What can we do to this?
2x minus 1?
Yeah.
2 square root of x.
Yeah, you could just do this, right? I mean, you could take the coefficient 1 plus 1 and just add them together because it's the same square root. All right, this is the limit. You okay? Guys, what I just did will make so much more sense next Monday, Tuesday. Because Monday and Tuesday, I'm going to give away the secret. What we're really doing here is, we're doing this. I can't tell you. If you really, really want to know the secret, read the next lesson, 12:30. It's pretty cool what we're doing. Calculus is all about this. This is what calculus does.
I think Colton was right though. When he said like, it's just
Oh,
finding
is it?
1 over the conjugate. Because
Is that what it came out to yesterday too? When you
the
did it?
assignment, and then that's what this one just came out to. Was 1 over the conjugate.
Oh, yeah.
The simplified.
So the conjugate was this.
Yeah.
That was the conjugate?
Yeah.
Ah. And it happened in your assignment over and over?
Couple times.
Yeah, here's the conjugate, right?
Yeah.
With a plus.
And everything just crosses out.
Oh. Well, I don't want to say it. It could be. I don't want to say it because what if there's a problem out there that it doesn't quite work, and it's a good observation you're making though. Yeah,
Could you help me?
I can. You know, are you talking about yesterday's lesson?
Yeah.
Yeah. Can I just do it?
Yeah.
Because I have a feeling everybody out here probably needs help, so let's do it together. Which one?
Number 17.
17.
Yeah.
Okay.
Okay.
17.
So,
You know what, Olivia? You don't even have to tell me.
alright.
I've done it for every class. X to the 5th minus 32 over x minus 2. Find the limit. As x approaches what?
2.
2. Okay. I'm going to try it, even though I kind of know what's going to happen. Direct substitution. This would give me 2 minus 2, 0. This would give me 32 minus 32. 0. What's that mean? It does exist. Oh, well, if it exists, let's go find it. But the question was, how?
Do you mean like simplifying it?
Yep, I mean you gotta simplify that thing.
What I did is that, you know how you have square roots and then you kind of factor that out into smaller binomials? I did that. So I got like x minus 2 and x plus 2, x minus 2, x plus 2, x minus 2. Is that correct?
So you're saying the top
Yeah.
is what?
X minus 2, and then x plus 2, x minus 2, x plus 2. No, another x minus 2.
Wow. Is that, how'd you get that?
I don't know.
Oh, you don't know?
I just took x plus x to the 5th
Yeah,
minus 32. 32 is the 5th root of 2.
okay.
And so kind of what I thought is.
Oh, I think I know where you're going. You're thinking of difference two squares, and then you're just kind of continuing the process on. Something like that.
Is that right?
It's not right.
Okay,
I didn't tell you.
I accept that.
Okay, good try though. You know what she's trying to do? She's trying to cancel the x minus 2 with the x minus 2 and call that the simplified answer. She's kind of on track, but I gotta speed you up because the time says 5 minutes. Here's what you. This was a bad problem for you because I never showed you how to do this. I told you guys to factor. You don't know how to factor the difference of 2 perfect fifth powers. This is x to the fifth. This is 2 to the fifth. You don't have a formula. You could do perfect cubes, you could do perfect squares, but not this. So then you have to think of it like this. This is just a division problem. Just divide them. Long division or synthetic?
Synthetic.
Thank you. I didn't want to do long. Okay, so I'd go like this. Put the 0 out here. The 0 is 2. Then I'd say put the coefficients here. Okay? Why do I have all these zeros? X to the fourth, third, second, first. Okay, I have to go fast. So here we go. 2 times 1 is 2. Add 2. So multiply. Add, multiply. Add, multiply. Add, multiply. Look what I get. I get a remainder. That's your remainder of what? If your remainder is 0, then that means x minus 2 is a what?
Factor.
Factor. X minus 2 is a factor of what's up above, which also means this times this would give me what's up above, right? So I'm going to write this for you. Up above, you can rewrite what's up above by going like this. X minus 2 times x to the fourth, that's this one, to what?
X to the third.
Okay, 4 what?
X squared.
Please excuse this interruption for one short announcement. Girls softball practice will be held at 4 o'clock today in the new gym due to weather. 4 o'clock in the new gym. Boys basketball open gym will be postponed till next week. Thank you.
Okay, see what I did? I canceled out the x minus 2 with the x minus 2. What's left is right here. Then I would do the limit. As x approaches, I can't remember. What are we approaching? 2? Which means direct substitution here, 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 here. What is the limit? I'll let you figure it out. I mean, that's not the hard part. Putting the 2 on there.
In the back of the book, it said 80.
It is 80. Because if you put 2 in, you'll get 80. Olivia, did I go too quick?
No.
You're okay?
Yep.
All right. Everybody else? Did it kind of make sense? Here's the problem. You guys were, it was a setup. Yeah, it was like, I knew you were going to come to class with that question. Because if you didn't answer that question, then I know you need to be home. So at least I know Olivia ran into that problem. Did you guys run into that problem? Did you have a hard time? Because you couldn't do what? You couldn't factor. And if you can't factor, I don't know what to do. Yeah, you do. Long division. Oh, sorry. Don't do long division, do what?
Synthetic.
Yeah, it's much easier. Yeah. It's just not a very fair problem, but oh well. Life's not fair. I hate to tell you. Okay, so everybody got their what? Progress reports, right? If you have a problem, like Kaylee had a problem with something, she's gonna talk to me. Anybody else have a problem? Like you didn't take a quiz, you didn't? You saw your test score? Yeah. You saw yours? Oh, retakes. If anybody's interested in retake, talk to me. You don't like the grade, you might want to take one retake. What is it? The drafts. You probably, what happens is, It's gotta go from the paper to the book to the computer and then they get. So. Okay, here we go. Right here. Right there. It says a 7. 9. That's probably because you must have missed 2 of them. And I probably took out 2 points. So you don't have that score? Is there another one? Are you missing other scores?
I'm just missing that.
Okay. So, you want me to write it down? And then I can change your progress report? Okay.
I don't really care about my progress reports.
Oh, you don't care? Do you want to just see it?
Sure.
Like what it comes out to?
Yeah.
It won't raise your grade more than maybe 1%, maybe? I don't know.
Oh, my test raised more again.
Okay, 10, 8, the graphs, 7, right?
Yeah.
So you went from 66 to, 67. I mean, it went up a little.
Yeah.
Okay, wait a minute.
I think that's.
Oh, no.
What is that?
You have all the other.
Oh, I'm
No.
so confused.
No, you have other. You have numbers everywhere.
Okay.
Yeah, you're good. So now save that. Okay, and hide that. Okay.
No.
So you don't care
No.
about your progress report?
Because I can just like check on our school and stuff.
Right. So,
Thank you.
alrighty. Jordan, how you doing?
Let's see, last test.
The last. Okay. How'd you do?
I saw the not.
No, but you saw it. Did you get a score?
Yeah, I saw the score.
Oh, okay.
Can I see like what I did wrong? Or
Yeah, no, you can't. It's just, how did you do it?
It was like.
Was it C or was it
No, it was like 73.
73? Okay.
So I told you as I turned it in, I'm gonna retake.
Okay. Alright, Matt. Oh, wrong class. Cornelka, wrong class. Skyler. Okay, here we go. Here's Will. 12-1. Here's another 12-1. Oh, wait, I didn't find that for a second. Okay. Okay. Period 6. I gotta find that person tomorrow. Yeah, no, I wasn't there. Yeah. Here is math modeling. They eventually turn into this assignment right here.
Okay,
Which,
so this is
which is
421s.
yeah, but today's 422,
22. Yep.
and then you'll see some oddballs in the front.
Okay.
I can't remember if I changed it right or not. So there you go.
Food.
And then here is Hannah 6'5". Don't count Hannah late. She's been sick for 3 or 4 days.
Okay.
Ethan 12'1", Will 12'1".
Late or not?
No. Well, wait a minute. Will. No, I'm not gonna count these later. I wanted them to do them the best they could. This doesn't
Okay.
look very good, to be honest.
That's it?
Oh wait, period 6 is probably on that far next.
What assignment? Is this more 12-1s?
Yeah, I think those are 12'1s".
Okay.
Who gave it to me?
We've got Siri, Clay, and Tierney.
I
That's
still
it.
have to turn it
Nobody in period 6. Did period 6 do a good job? Handing them
I didn't do too bad.
in? Okay.
There's 6 missing.
6 minutes out of 15. That's not
Pretty
great.
close, yeah.
Alright, and you still gotta hand yours in?
Mm-hmm.
Okay. Clay, Jordan. There you go. Okay, tell me how many wrong you got in the first page.
6.5.
How many on the second page?
1.5.
Okay, third page.
3.
Oh, okay. A lot of people,
It was all on the rook one.
oh, did you not even try it?
No, I did it, and I don't know. I guess I didn't know what you wanted as the answer.
No, I can't remember what they did, to be honest. I'd have to look at it.
And then identifying the graphs based when you just give us r equals 3 minus 3 cosine, like that.
No
I
idea.
can do it with pictures and,
You can do it with pictures?
but yeah, because the whole top part was fine, and then just like,
Oh.
to identify those and what they
Yeah,
are.
you know what you had to do there? You had to make a little, like, off to the side, you make a sketch of it, like.
Yeah.
Did you make the wave?
I mean, all 4 of them right there, except for 1.
Okay, so, you did, is this A?
Yeah. It's the order that they are, I just
Oh,
want
okay.
to see.
So here's A. Negative cosines down here, up, down, up, okay. And B. 4 up, 4 down, okay, lift it a little higher, yeah. Gotcha. C, this D, okay. 2 plus sine is. So sine is just up 1, down 1, right? Okay, so up 1, down 1. But if you lift it up 2, it's up 3. So there's 3. 3 should be the highest it goes.
I thought that was the 3 that would go up to.
No, but see, the 1 is the amplitude. So 1 and negative 1. So it just goes back and forth, 1, 1, you know what I mean? Then this is the vertical shift. So if 1 was the highest, now 3 is the highest, right? And if negative 1 was the lowest, up 2, now 1 is the lowest. So the wave starts at the midline, up to 3, there. You get what I'm saying? Okay, and you touched the pole. That's what got you. And then I don't know what you're doing there, so. It kind of looks like what you're doing is you're drawing a lot
I
of,
just didn't have the information in my head, I guess.
so, well, that one, to me, 3, whenever you get 2 theta, 3 theta, 4 theta, it affects the period from 2 pi, short. You know what I mean? So your period is 2 pi divided by 3, which means your period happens in 2/3 pi. So if this is 2 pi, 2/3 of a pi, here's pi. By the time you get about here, you're done, right? Cosine starts high, goes low, back to high. There's 1 period. 2 periods, 3 periods. So you have multiple periods between 0 and 2 pi. This is the rows. You know what I mean?
Yeah, I knew that was a roll.
Oh, you did?
But theta was.
Okay. So which equation's polar graph is a cardioid? Cardioids will only touch the x-axis once. Just A. I gave you credit for this, but then I had to take out half a point for giving you D. Because D doesn't really touch the x-axis. Although you thought it did, and that's why you put D. Right? And then this one. Which equation is polar graphs? Yeah. Yeah, you were guessing.
Yes, the roll was 9%.
Okay, that's no problem?
Might as well.
Okay. Yep, this one is, okay, did I say the radius is 1? That's, shoot, here, the radius is always gonna be x squared plus y squared, take the square root. X is the real number, and then y is the number in front of I, 1 plus 1. So it's 1 squared plus 1 squared, which would be the square root of 2. And you put, well, you thought it was the square root of 1. That's why you put 1. 45 is right, because all that is tangent of theta equals.
So why didn't we add 45?
Oh, okay. So then, hang on. Okay, so this is 45, right? I agree with that. Okay, now, do you understand that if I want fourth roots, you have to take the fourth root of the radius? Okay, so square root of 2 is really 2 to the 1/2. The fourth root of that would be 2 to the 1/2, raise it to the 1/4, which would be 2 to the 1/8. Or the 8th root of 2. Are you okay with that? Perfect? Okay, so why is it not 45? Because here's why. When you take 1 plus I and you change 1 plus I into polar form, in polar form it's going to be your radius. Your radius was the square root of 2 times cosine of 45, right? Plus sine of 45 I. 1 plus I is just this in polar form. Okay, now I want the fourth roots of that. Well, this is where you say, if you had your formula sheet, you take your radius, to the nth root of your radius, well that's the fourth root of your radius is this. Okay? Then you take cosine of your angle, and what do you do to your angle if you want the fourth root? Divide by 4. So if you take 45 degrees, divide by 4, you get 11/2. Does that make sense what I'm doing? I don't have your.
That's the fourth one.
Yeah, here. No, listen. This is polar form.
Keep going.
This is polar form. Okay? So now, this is this in polar form, but when you want roots, you take your angle and divide by 4, because it's fourth. If this would have been cube root, divide by 3. Okay, so now divide by 4. Bam. Now, what am I doing to get to the next one? And then the next one? And then the next one? Why? Yeah, it is on the formula sheet, but here's what I did. I said, if your first angle, okay, watch this. Cosine, if I said this number is your radius, and by the way, that number is really tiny, it's like 1.1, which would mean I'm going to go out 1, 2, I'm going to go out 1.1, right here. I'm going to go up 11 degrees. Down here. So there's your first root. Now there's 4 roots. If you make a circle with a radius of 1.1, all roots are evenly spaced around the circle. So if this is the first root, the next one, if they're evenly spaced, will be like this. So 1, 2, 3, 4, repeat. So here's what I do. I just say, well, since this is a circle, 360, there's 4 of them. They're all 90 degrees apart. So then I add 90, 90, 90, and then I'm supposed to write this stuff. I just didn't. So now here's my question. So what if it was cube? What would you add? Yeah. What is it? Yeah, so you go 11 degrees is my first answer, add 120, add 120, and I'm done. Because if you're looking for cube roots, there's only 3. Fourth roots, there's 4. Fifth roots, there's 5. Okay. For the most part, Jordan, I mean, this is a 4-point problem. You got all the angles wrong, you got the radius wrong, it was hard for me to give you much more than 1 point. But I mean, I see your work, I see what you're doing, you got this right. Yeah, you did get that right. So, okay. You okay now with that one? Okay. All right, what happened here? This is this. That's good. Now you want x, so you took r times cosine. R is negative 3, cosine of negative 240. That's it, you got it right. Y is r times sine, negative 3 times sine of negative 240. I have no idea how you got 2 over, is that a 2?
Yes, it is.
Well, first of all, 2 over 2 is just 1. You could have just said negative square root of 3, but that's not right. This is what you should have got.
That's just
I don't know. Not sure. See, I'm not sure how you got this right. And then all of a sudden, you got that wrong. It's weird. I'm sure you punched the wrong button, Jordan. This is my guess.
Yeah, I just wrote it wrong.
Did you?
That
What was it?
That's
Oh, did you really? Copy it? Huh?
Just writing it wrong, I guess.
Slow down. Slow down. Okay. All right. So you know what you're doing, right? Okay. Here. Okay. Let's see. 1, negative 4 is rectangle. Find 2 pairs of corresponding numbers. R theta. Well, R is just x squared plus y squared. Take the square root of it. You did it here. You get the square root of 32. Which you simplified to this. Okay. No. And then theta is negative 4 over 4. It is oh, you went into radians, did you? Okay, so you okay, yeah, but you actually must have typed it into your calculator. Yeah. Okay. See, negative 1 to me, negative 1 just means. To me, it just means this. Negative 1, 1. So to me, that's 45 degrees. Or you could have just said negative pi over 4. Negative. Right? I mean, I get what, I mean, you understand that it's just, it's just 1 over 1, so it's the special triangle. So you could have just said negative 45 and been done. But you actually took that, and that, and that. Good job. Good job. So that is correct. This one I like. Here it is. Yes, I wrote yes. Now this one. Oh, what are you doing? Now you changed your radius to negative, but did you? No, you left your radius positive. I need it negative. Okay, so now,
This is what I did, from the negative down to there is gonna happen, and the other only thing I'm gonna do is go from there. I don't know what else.
Alright.
Then how else you can describe that point, you can either go negative.
Yep.
Instead of negative point,
Mhm.
or go.
Oh, I get what you're doing.
positive,
Yes,
positive.
now you're going this way. I got it. This is what you're doing, right?
Yeah.
So positive 5.4, whatever this is, 98. That is correct. But you gave me a positive radius, you gave me positive, and then you gave me.
Both the radius are positive, how do I make it negative?
Well, here's what you do. Now you do r less than 0. So you do negative 4 square root of 2.
I just randomly turn on negative.
You can, yeah. Oh, you can do many different things. Okay. Now here's 4 square root of 2 over here. Now negative 4 would be 1, 2, because I don't even know where that number is. But let's say it's over here. Now I gotta get to that point. From there to there. How do you get from there to there?
Yeah, I did all those things.
No, you do?
Yeah, I was
Okay. Well, can I tell you that all it is this though? All you have to do, I'm trying to find out what your answer. Oh, here's your answer right here. Your answer is 4 square root of 2, comma, negative 0.785, right? if you change this to negative 4 squared root of 2, this angle right here makes me go this way. Right over here. This angle makes me go this way because it's positive. No, because it's negative. So I went this way. I want to get way over here. So you know what you end up doing? To get back to here? Add pi. So if you took that answer, negative 0.785, and you just added pi, you'd get it. I feel I gotta show you something because I don't think you get this. Ready? 3 comma 60. Okay. Okay. So here's 360. 1, 2, 3. Up 60. Okay. Now, if I change it to, if I change the radius to negative 3. Okay. 1, 2, 3. See that? See that 60? That 60 is right here. This way. Is negative 360 gonna get me that point? No. So what do I do to get over here? I can add pi, or I can subtract pi. And since I'm in degrees, I can add 180, or I can subtract 180. So the rule is, if you change your radius to negative, or if you just change it to the opposite sign, take your old angle and add pi or subtract pi. Not 2 pi, just 1 pi. Does that make sense? Okay, that's all that is. If you want to leave it as 3, go ahead and leave it as 3. Then 360, give me another answer. Well, then you just do what? Add 360. So 360 is the same as 420, right? Hopefully that helped you a little bit. Add 360 or 2 pi when you leave it the same. But when you change 3 to negative 3, just add pi or subtract pi. All right. Now, we're almost there, Jim. We're almost done. Good?
Mhm.
All right.
Is that it?
I think so. Math modeling, 12-1.
Yep.
Yeah, that's it. Tomorrow, there'll be a lot of math modeling
Okay.
because they quiz
Okay.
and the homework comes in. Pre-calc, there won't be any assignment, but I think I'm going to give them a problem as like a little homework quiz,
Okay.
just to see if they're kind of up with me. And it might just be correct it, Gabby, and just put a score in.
Sounds good.
Okay? All right. Anyways, so you're okay. How about this one? Okay. Everything you know, huh?
Type of thing up there, any
Any.
math, just
Well, here's the
doesn't
thing.
even make any sense.
Do you know what you're doing? Like, what are they asking you? Okay, write the equation. 2xy equals 4. As an equation in what? Okay. So polar is this. R theta. You can't have x's, you can't have y's, you can't have what? R's and thetas. Okay. And in your formula sheet somewhere, I bet it said x equals y equals. What does x equal? Right? So guess what you put in for x? 2 times, what is x equal? R cosine. Guess what you put in for y? R sine. Wait a minute. What's the problem say to do? Get it out of rectangular, that's why. Get it into r theta. Where's the xy? I don't see xy. Do you see xy? No.
that, that's why I didn't know.
No. I'm not telling you it's a,
Coordinates.
no, I'm not telling you it's an ordered pair. I'm saying write this equation, which is rectangular, as another equation that's polar. Do you see an equal sign? That's your equation. Do you see polar? I see thetas, I see r's and thetas. Okay, you know what some students did? Some students did this. They divided by 2. Bam. So then they wrote this. R cosine of theta sine of, I did that wrong. R sine of theta equals 2. Some students did that. Didn't need it, but they did it. You know what other students did? They took r times r and got what? R squared cosine of theta sine of theta equals 2. Then you know what some students did? They solved for r. 2 divided by what? Cosine theta sine theta. This is all unnecessary, but some students kept going, Jordan. You know what? There's even another thing I could do with this. You want me to do it? No, you don't care, do you? You don't care about this, you don't care about this, you don't care about this. All you care about is get rid of what? X and Y. Is that hard? Not at all. That is so easy. You just gotta follow the formula sheet. Now, do you remember what else the formula sheet said about tangent of theta? What's tangent of theta equals? Y over x. There was one more thing it said. It said r squared equals.
X and Y.
What?
X and Y squared plus X squared. Or plus Y squared.
X squared plus y squared. Okay. Gotcha. All right. Now, the reason I'm writing this down is because of these two. Okay. I'll keep that visible for you. All right, so you got what? R equals 2, right? Okay, R equals 2. Identify, tell me what kind of graph it is. And not only identify it, graph it. Each equation by first transforming it into regular form, x, y. I need R to become x and y's. Okay, I like what you did there. How did you do that?
Squared R.
Squared R.
Make that equal X squared plus Y squared.
Okay. So you went, I think, without showing your work, I'm not sure if you did this, but it looks like you squared your R and got what? R squared. R times what? 2 times 2. 4. Then you said R squared is really this, right? Okay. Right? And that's that. Then you divided by 4, you got 1, x squared, y squared, 4. Okay, got that. But, okay, then you graphed it. Did you know this was an ellipse
Yeah.
that has a radius, or an a value of 2 and a b value of 2?
Yeah.
Which basically means it's a circle. So, it's a circle. You will also know it's a circle when the coefficient 1 and 1 are the same coefficient. Okay? If 1 and 1 are the same, it's a circle. Okay? You know, you didn't have to do this from there to there. See this? X squared plus y squared equals 4 is, by definition, a circle. If you just have x squared and y squared, this number over here is the radius squared. So take the square root of 4 and you get 2. I mean, you did a pretty good job on this one. But to be honest, you didn't write a circle. So I should have taken out another one. Oh, I did point at this. Yeah, but why'd you erase it? You don't think that's a raise? Alright. I did a nice job of finding a smeared answer, by the way. I think I did a nice job for you.
What is that erasing other things up here? So, just that column.
Alright, ready? What's wrong with this one? You got
I
theta.
just didn't know what I could do with just giving it one.
Okay. Theta equals pi over 6. Look here. Let's try get this to be just x's and y's. If they tell me my
X
a
is 60.
x is what?
Or the x is not 60. It's the square root of 3. And y I put it up here.
Okay.
So if I would graph it like a rectangle, it'd be up there and then down, and then this is the 30, so across from it would be 1. And then this bottom part would be the square root of 3.
Well, here's what I'm trying to get to you. I'm trying to get this across. Okay. Here's theta. Here's pi. Theta equals pi over 6. But it says here tangent of theta should equal y over x. Well, I'm giving you theta. Theta is what? Pi over 6. So why can't we put pi over 6 in here? And theta, tangent of pi over 6 should equal what? Y over x? And you already did this, I think? Oh, you got square root of 3 over 3. Good to know that you're doing it. Are you doing this, or is it calculating it? Why would you do it? Well, pi over 6 is doable. I mean, it's just a 30. Okay. So now, to me, if I get it in rectangular form, I would solve for y to see what it is. Cross multiply, 3y.
So I already assumed if this or this equals y over x, that's why I assumed this is y and that's x, but that's why it's not right. I thought about that and I thought, well, that's not right then.
Yeah. Well, I think
That's
with
why I
here,
plugged it in
here,
right then.
if you went like this, if you'd said something like x comma y equals this point square root of 3, then I can see why you'd say, oh, this is 3, and this is this. But this is an equation that can be solved. Cross, multiply, divide by 3. What does y equal? Square root of 3 over 3x. What form is that? That's not a circle. That is linear. Yeah, it's just mx. Y equals mx plus b. There's no y-intercept. So really, this one should have just been linear. That's identify, linear. Then graph it. You can graph this on here if you want. It's the same thing. But it's really difficult to graph this on polar. It's really difficult. So what I need to think of is this. If somebody told me theta is always pi over 6, what's pi over 6 by the way? 30 degrees. So what I'm telling you is your angle is always 30, right? If your angle is always 30, then that R value can be what? Okay, watch this. X equals 2. Graph x equals 2. Tell me how that graphs. How do you graph it?
Right. Straight line.
To the right and then what?
Straight up vertical.
Vertical. Okay. So what this says, x equals 2, says this point 2, 0 is on the line. So is this point 2, 2. So is this point 2, 5. What does this 2 say? X has to be 2, 2, 2, 2. What can y be? 5, 2. You can do what? Anything. Okay, if that's true, then what I'm asking you is, if theta is 30, what can r be? Anything. Give me a number. 2, 2, 30. Give me another one. 1, 30. Give me another. 3, 330. Okay, let's just graph this, ready? 1, you said 130, so 130, 330, where's 330? Oh, yeah, kind of that one. 230. How about 530? How about 630? See it? It's a what? It's a line. It actually continues, it goes that way.
Yeah, I guess I know you can have one. I was
Well,
thinking
but
of all
I know,
the
okay,
different-
you know why? You know why you didn't know that? Because I made you graph, you know, like this says theta equals pi over 6. Here's what I've been doing to you. I've been going like this. I've been doing those. Like I do 2 sine of theta, which turns out to be a line mesone. Okay, so that's a line mesone, but that's not what I gave you. Here I'm just telling you theta is what? Always pi over 6. Where's pi over 6? 30 degrees this way, right? And this way.
That's all.
Can I tell you this? This can be done in 2 seconds. If the radius is equal to 2, that just tells you the radius is 2 all the time. Give me an angle. Give me an angle. 30. 30, 60, 90, right? Okay, where's 230? There's 2, there's 30. 260, 290, 120. See? Where is the radius always equal to? Right there. I mean, really, there wasn't much you had to do here. You made this hard, I
That's basically.
think. Nah, that's all of it. But Jordan, you know what happens on a retake test?
They're different.
What happens is you did well here. You can't forget this. So what are you thinking? Like, are you yeah, those are the, are you thinking, you're just gonna go home and relook at some of this, or what?
I don't know, 'cause I have to do all of the homework in this chapter.
Yeah, I know, but I don't think I would just cold turkey walk in and take this.
I won't. Maybe on Monday. Look at it.
Oh, you're gonna wait till Monday?
Yeah, I can't.
Can't? Don't you feel like if I just talk to you right now,
Promise.
you don't think like going home tonight and trying a few problems? And then take it tomorrow? Cause you wait a weekend,
Yeah.
I don't know, I just feel like if you wait too long, another weekend might just erase your memory. It's up to you. You sure you can remember, keep this in mind how to do this? What's going on tomorrow?
I have to get a ride with someone, so I can't stay. So,
You have to get a ride with someone.
yeah, 'cause we have a thing when I drive to medical careers.
What you're saying is, you don't have a car after.
Yeah, I have to ride.
Okay. Well, I just know the more time that goes by, and the more you hear about this stuff, the less you remember this. So. But do you feel like,
Refreshing Monday.
do you feel like this is okay? Like the mistakes you make, you feel like you get them? Okay. Okay. What's up?
The next one we test.
Oh, you saw it already? Okay.
I thought I was gonna do awful. No,
What'd you do?
I got 33 out of 40
Okay.
to see.
Yeah. So you saw it, right?
Yeah,
Okay, so you're okay with
it
it?
was just little mistakes. So, it wasn't that bad. They're pretty good for cramming it all in one day.
Yeah, okay. So she did this. All right. So I had, oh, here it is. I have your progress report. I was gonna give it to you guys today, but we just kinda,
Okay. You can give it to me.
Huh?
You can give it to me.
There you go. Oh, that's a quiz, no wonder. Okay, I was thinking it was your assignment. I was thinking, why is it at 20? There's something wrong here.
I know.
No, there's something wrong with these numbers.
Yeah.
So 10-2 is out of 10. Zips is out of 9. Legal reclamation.
I got like a 2 out of
Yeah,
9.
But I was trying to tell you that this worksheet, I remember this worksheet when you handed it to me.
Yeah,
It wasn't done. Like, it was just partially done.
it wasn't done.
No. I remembered this. I go like, oh, she didn't do much on this.
No,
Unless you did it on a separate sheet of
I
paper.
probably did, cause like I gave everything I had to you. Is that? Oh,
10. What would this is, I think this is.
was it the one where I had to like put the graphs on there or anything like that?
Okay, I gotta switch this because these are wrong.
Okay.
You know, because this will help you because 8 out of 9 is better than 8
It's
out
just
of
that 2 out of 9, cause I always do my work, so I don't.
10. Well, you can look it up.
Yeah.
It's in there. It's just probably buried because this was actually, this was April. I put this in April 20th, which meant you probably gave it to me around April 15th.
Right.
So this is a good 3 weeks ago or more.
Where? At what pile at?
That's a good question, Jimmy. I don't know,
Oh god.
but I can tell you it's gonna say right on top, trig review. And here's the other thing: if you gave it to me with your class, it's all in the same pile.
It's not this, is it?
No, it's a worksheet that says trig review.
Trade review.
And Jamie, if I had to guess, my guess would be in the other pile. Not that pile, the other pile. And deep, like not on the top. Middle to bottom. That's just my guess.
Okay.
Could be totally off. Could be in the other pile. Okay, so